Okay, so we're going to take a look at a couple of problems from the Chapter 3 quiz by request. I'm not going to solve all of these to completion, but I'm going to give you some tips and tricks if you need them. So let's take a look. I'm going to expand the problem here. And for the first one, we've got phosphorus has molecular formula P4 and sulfur as S8. How many grams of phosphorus contain the same number of molecules as 6.41 grams of sulfur? So for this one, we're going to have to figure out, well, how many molecules of sulfur do we have? So the first step is to go from grams, and we can't go from grams to molecules directly, so we'll go to moles and then molecules, and we'll have that for sulfur, and then it's just a matter of going from there to grams of phosphorus. And that's P4 here and S8 there. So again, you won't be able to go directly to grams, but I'll leave it to you to figure out what to do from there. Next up, this is a classic kind of AP type problem. We've got ethyl butyrate, which is a compound that has carbon, which we don't know how much, hydrogen, and oxygen. And combustion, so you should know combustion means reacting with oxygen, produces and we know we have 2.78 grams, and this produces carbon dioxide, 6.32 grams, as well as water, 2.58 grams. So we don't know the balanced chemical equation here, but we do have enough to figure out how many moles, okay, we have of each of these substances. And the key for this type of problem is to recognize that the moles of carbon dioxide right here, okay, means that you're going to have that many moles of carbon. Okay, so the carbon moles is from CO2, and then the H2O moles, that is going to be, now think about it, you got 2 hydrogen for every 1 water. That's going to help you get the moles of the H from in the original equation. Now from there, you're going to have to do a little bit of process elimination. You know you have 2.78 grams, so you can kind of figure out, hopefully, what's left over to figure out the moles of oxygen. And then the last piece they do give you is that the molar mass of this substance should be between 100 and 150. So if you get an empirical formula and you add up the molar masses or the atomic masses of all the atoms and you don't quite get 100 and 150, then you know you have to do something else with that. So that's that problem. So to see if you can take it from there. And then the third problem here, we've got 2 isotopes of mass 68.95 and 70.95 respectively, and then you have abundances. So this is a classic average atomic mass. This is what's known as a weighted average. And here you simply have to take the masses and multiply them by the abundances and then add them together. Okay, so I'll let you figure the rest out there. And then the last problem that was requested for this chapter is the following: a 2-gram sample of oxide of bromine. So that means you got bromine and you got oxygen. Is converted to 2.936 grams of silver bromide. So I've got 2.936 grams. And I want to figure out the empirical formula for that. And they do give us the molar mass of the silver bromide. Okay, so we don't have to hit the periodic table necessarily. So for this problem, what you'll need to do is, and again, a lot of these problems where you only have certain numbers, you don't have too much information, keep it simple, take it to the next step that you can do, and that is you can figure out the moles of this substance. Okay, and see if you can work backwards to figure out how many moles of that substance there would be. And if you know how many grams you have, and you know how many moles that is equivalent to, you should then be able to figure out the molar mass of this substance, which can then lead to the empirical formula. Okay, so see if you can take it from there. And this, again, is some tips and tricks for a couple problems in Chapter 3. If you ever have any requests for problems, please send them my way, and we'll do a quick screencast just like this for the problems that you request.